Now, don't worry if it seemed like, well, that seemed pretty generic. We talked about planning an IP addressing scheme, asked me a few questions that we need to look into, and then we moved on. We're moving on because you need to understand a lot more about how IP addresses work so that you can then answer those questions generically, but then answer them with, well, what IP addresses are we going to use? Okay, so this is going to all come together here after we go through all these different rules and how IP addresses actually work. So I already mentioned to you that each of the four numbers in an IP address is referred to as an octet, meaning each of the four numbers is actually an 8-bit binary number. A bit in binary is a 1 or a 0, and each octet or each number in an IP address can only be ranging from 0 to 255. Hey, I think we've seen those numbers somewhere before. Yeah, I know. Oh, yeah, that's right, in the subnet mask. Remember we saw it was all 255s or zeros? Well, that's because technically a subnet mask is not about the 255s and the zeros. It's about being all ones up to a certain point and then all zeros. But again, I don't want to jump ahead of myself. When we get to the binary math lesson, you'll see how that works. But I just want to show you quickly here that the reason that it's all zeros in a subnet mask is because 0 represents the 8-bit set of zeros, okay, all zeros. And the 255 is the 8-bit range of all ones. Okay, if you take 8 ones in binary and put them together, I'm telling you it equals 255. We'll do the math later, but right now you're just going to have to trust me. Another rule of IP addressing. The first octet, okay, so the first number in an IP address cannot be 127. Okay, that's just a defined rule. The 127 range, okay, so all the IP addresses that start with 127, they've been reserved for diagnostic purposes. Now, it's interesting that we've reserved all these IP addresses, everything that starts with 127, and I will tell you that's like a little over 16 million IP addresses that if you do the math, and again, we'll get to the math later, that all start with 127. The reason it's interesting that they've reserved all those IP addresses is because there's really only one that is used for all practical purposes, and that's the IP address 127.0.0.1. This is what's known as the loopback address, and it's also sometimes referred to as the term local host, meaning myself, pointing back to me, my own IP address, my own network card coming back to me. That's what that IP address is. It's the loopback address. So some more rules. Don't you love rules? Some more rules of IP addressing is the host ID. Okay, so the host ID portion of an IP address cannot be all zeros or all 255s, or again, remember, anywhere you see all 255s, that actually means all ones. When the host ID is a 0, that represents the actual network ID. So when I say that the network was just simply known as 192.168.10, technically the way you would list the network ID, it would be 192.168.10.0. Okay, the 0 can't be a host. It represents the actual network we're on, the network ID itself. And you can't have all 255s or all ones for the host ID because that represents the broadcast address. Now, you might recall from a previous lesson that we talked about broadcast communication, which is where one sender sends out a transmission, and that transmission is destined for all computers on the network. That's a broadcast. So 192.168.10.255, okay, again, if we're dealing with the 192.168.10 network, that 255 at the end, again, that won't be tied to a single computer. That would represent the actual broadcast address. Okay, that represents a communication that's meant for all computers on the network. And that's why you can't have all zeros or all 255s in the host ID.